Welcome, everyone. I'm Dave Klein. This is a Cymulate cybersecurity broadcast. We have a phenomenal episode today, and there's a funny story behind it. I'll get that funny story in a second. Top secure programming and application development best practices with Tanya Janca. Tanya is here because I need her help so much. And before I tell you the funny story and why I need her so much here, I'm going to have her talk to you because she's been very busy, been doing a lot of stuff.
Hi, I'm Tanya. Thank you so much for having me on, Dave.
Great to have you.
So I'm the founder of We Hack Purple, which was acquired by Bright Security this year. And We Hack Purple, we used to have like this big academy where we sold a lot of online courses and this big community where we would do events together, hang out together, kind of share things, chat. But now, thanks to the acquisition, we don't have to turn a profit anymore. So all of our courses are now in the community, and the community has exploded. So we now have over 6,000 people who want to talk about the security of software or threat intelligence or like incident response, everything. So we have different sections for different areas, but it's been really exciting to see it just explode this year.
Yeah, that's so awesome. Yeah, congratulations. That's really kind of cool and well-deserved. I mean, you have a very active community, and it's so really kind of cool. And it brings up why you're here. So I literally, I do a newscast for my current company every week. And so in the morning, I get up and I have my cup of coffee, eating my breakfast, right? And as the cat and the dog sit there, I'm on my machine looking for news stories to collect over the week and to do in the broadcast. And one came up, Symantec came up with a study. I'm going to put it in the chat window here, which should be able to be seen on LinkedIn and YouTube in the notes section. And in it, it was covering the fact that they looked at so many mobile apps and said that so many of them had hard-coded either direct AWS tokens or third-party tokens and other things that were easily manipulated, right? Open S3 buckets with no segmentation and no permissions to get in and things like that, right? So you just open to the world. And I sat there and thought like, geez, if this were about operating system hardening, if this was about, taking least privilege practices and incorporate them, if it was talking about any kind of application firewall or anything like that, I'd be good to go. But in application development and programming, I realized I'm at a loss. And I said, I have to call Tanya. This is a perfect Tanya topic because it really is kind of critical. If you look at the things that the way they work today, everything is so based on DevOps and making it stick and understanding that. And from a cybersecurity professional perspective and a developer perspective, it's something we really need to know. And I think that's really kind of important. So thank you for coming here today. So in talking about DevOps and secure programming and app development, what are some of the main top issues you see in this?
So some of the main top issues, so a very significant percentage of vulnerabilities come from a complete lack of input validation. Or there is input validation, but it's not great. So what I mean is, let's say you made an app and you can search through a bunch of products on your webpage. And so there's a search field. Someone put something in there. So you or I, non-evil users, would put pants or a shirt or whatever it is we're legit looking for. But a malicious actor will put in something else, like perhaps script tags or maybe 10,000 characters to see if they can overwhelm you, etc. And so behind the screen, deep in the code, it should be asking, like, is this what I'm expecting? And if it's not, I should probably say no, thank you. I'm looking for, so let's say it's a search field. Most of your products are probably named with letters. With letters, and not necessarily with special characters like single quotes, double quotes, etc. What a lot of developers do is they will make a regular expression, which is a thing that you could, or regex it's called. It's like a filter that you could put stuff through. And so they'll look for the bad things. And if there's bad things, they'll say no. So that's sometimes called a block list. It's so easy to get around those if you are a pen tester or a malicious actor, like to just skirt around this list of bad stuff, because there's a bunch of different ways to express it. So if everyone did input validation and they did it with an approved list of what is allowed, and they do that validation on the server, so not up in your JavaScript, or it's in your JavaScript, but it's also down on your server. So your server is a trusted system. A malicious actor, unless they've infiltrated your network, generally won't be there. And if they were there living on your web server, they could do way worse damage than try to like catch something from the out. They're already in. Why would they bother, right? So If everyone did awesome input validation, seriously, Dave, it would be so good.
I agree. I think that makes a lot of sense. That makes a lot of sense. I remember one time trying to explain a buffer overflow to a bunch of people in a conference room. And I realized I was like the fourth person in the day to go, and they were looking tired. And in the middle, I was in the middle of the room, and you had all these tables, and they had M&Ms for each table. And it's one person who looked especially bored, this big jock looking guy. I go, come here a second, open your hand. I had him hold his hand up, right? And I said, now, buffer overflow. And I started taking the M&Ms and started putting in his hand. And the problem was, he was a big guy.
He had huge hands.
He used up the whole bowl. So I quickly ran and got another bowl. And by the time I got the second bowl, people were start going like, oh. I kept putting it in his hand as I explained what buffer overflows were. And finally one fell. I go, thank God. And they said, see that? One fell on the floor. That's a buffer overflow. Basically, we overflow this buffer. And that first thing hit the code is now going to do damage, right? And it was a hit. But anyway, that was my little story about that. But so that's really kind of fascinating. So beyond this input validation, right? There's other things that we see, right, in the ability to do session hijacking and sometimes hard coding of creds. What are other ways, other types of things that are problematic in coding?
Okay, so there are so many things. So one of the things that we see a lot of is cross-site scripting. So cross-site scripting is basically where a malicious actor has tricked your application into thinking that your code is actually its code and getting the browser's interpreter to interpret what you, the attacker, wrote instead of only what's part of the code. So you put some of your code where there should be data. So like, again, a search field, that's data. The search term that the user enters is data. And it should sit there and it should treat it like data. But cross-site scripting is where you've tricked it and you're like, yes, here's some code. It's not data, it's your code. You should execute it. And so the browser interprets it and then it can do a bunch of things. So cross-site scripting can basically do anything amazing that JavaScript can do. And JavaScript's quite powerful. It's basically the world's favorite web programming language. Yeah. It's quite popular. Yeah. And so we can avoid cross-site scripting with a few things. So one, input validation. It solves so many problems. So we start with input, and input can be from anywhere. So it could be from values saved in your database. You collect them and then you validate, is this what I think it is? It is, cool. I'm going to put it to the screen now. So then the second thing, and the super big one for cross-site scripting, which I would do first, is output encoding. So if you use something like Angular as a framework, or I believe React does that, Vue.js, they automatically output encode your stuff before it goes to the screen. So A+ to the people that made those frameworks by just building in security as a default, like, good job. I would like to give all of them a pat on the back. But for other frameworks or other programming languages, for instance, like older versions of PHP, it's not a default. And so when it goes out to the screen, if for some reason it's got past your input validation and there's some special characters in there, your screen, which is presented by your browser, it could be like, oh, wait, is that code? Oh my gosh, I'm going to interpret it and be so helpful for you. And then that is how most cross-site scripting attacks happen. So input validation, output encoding, and then the third thing that can really, really help with this, and there's more, such as testing or doing code review, et cetera, to look for these things. But the third defense would be using the content security policy header. So sometimes it's called CSPM, with content security policy header. But basically what it does is it lists all the resources that your website or web application uses. And so whenever someone does a cross-site scripting attack, usually they start with, hey, is it vulnerable? So they just want to see, are you vulnerable to JavaScript? And it's like, they are, awesome. But usually most of us, like if you have a search field, you only allow maybe 250 characters or 100 characters. And then you're like, that's it, that's all I'm allowing. You can't do as much damage with that. So the second thing they usually do is call out to one of their websites, like a malicious site on the internet, to get a whole ton of code and get it to execute that for them. So when you do the content security policy header and you say, okay, so I'm gonna, let's say, accept external resources such as something from Bootstrap. Let's say you're using the Bootstrap JavaScript framework. Cool. So you allow stuff from Bootstrap. I think it's .com. And let's say you want to use some Google Maps stuff. So you're like, google.com's cool. And you list a few places where you intend to have stuff. When this attack happens, their attack website's not on your okay list.
Right.
And so then it goes to call out and it dies. So these three things can be used to make sure you don't have any cross-site scripting problems. It's pretty cool. There's more options like as we get more advanced, but for now, like if everyone did those things, the internet would be really much more safe. Trust me.
I believe you. And I think, and expanding upon that idea of the fact that, cross-site scripting means you're pulling in code from other places. Yeah. Let's talk about the fact that, today you have Python, right? And you're again, we were talking about, I'm very good at scripting and doing all sorts of things. Programming was not my thing. I'm kind of okay. So Python, I get Python. But Python's a great example of pulling in libraries dynamically from the internet, right? I'm making a calendar application. I could pull a calendar application down. I could pull in all sorts of other major parts of the application. So my Python script shows me calling out these things, right? You also have GitHub, right? And other types of compendiums like this where people pull their code from. What are some of the ramifications of pulling in a Python from and borrowing libraries and other types of code, and also the idea of GitHub? What are some of the things that cause issues there?
Okay, so I'm going to split this issue into two pieces. So there's one, libraries and third-party components, NuGet packages, plugins, Ruby gems, etc., that are compiled into your application. Okay, so those are the supply chain to create your application. Then there's some that come in live. So as your application's on the internet, if you're using, let's say, like API calls out to Google, or you're using scripts from jQuery or Bootstrap or whatever, those you pull live. So I remember saying to some devs, do you have any things that you pull live, like they're living on the internet, that get updated on their own in your app? And they're like, no. So I turned on CSPM and put 0, like don't let anything in unless it's from my domain. And then their app looks terrible. And they're like, oh, we pull a lot of stuff from jQuery. I'm like, cool. Like we can trust jQuery. Right. Those guys that company and group seem good. Like they have good reviews. Okay. And so we ended up having to add 3 that are pulled live. So for stuff that's pulled live, 1, only pull stuff from places you know. Oh my God, please don't pull stuff if you are not certain. So do I trust that the Google developers are not going to try to attack us through Google Maps? Yes, 110%. I feel we can trust that sort of thing. But if it's random stuff on the internet or small individual groups, I don't want to trust it live because they can update it and change it, and that will affect my app. So for the stuff we compile into our app, like let's say we're using Ruby on Rails and we're taking a Ruby gem, which are open source. Yeah. You have a bunch of options. So the easiest one is to use a software composition analysis tool. So sometimes known as SCA, or if you're once in the blue moon, I hear people say ska, which is a type of music where it's like kind of punk rock, but with
I love ska.
Horns and stuff. And so
you're younger than me, but do you remember Madness, the group Madness from Britain? No, they were British ska. Phenomenal. Okay. I'm sorry, I digress. Go back.
No, but I always immediately think of a ska band every time someone says that, and I'm like, wait, nope, back computers. That's what we're talking about. But so these SCA products, basically what they do is they take the list of all the things that are in your app, and then they cross-reference it with a list of things that they know are bad. And some of those are things that have a CVE, a common vulnerability enumerator number, and it's publicly well known. But a lot of them are things that company researched itself. Like they have tons of researchers. They're looking through like each one of the packages to see if there's vulnerabilities. People are reporting vulnerabilities to them. A lot of them pay out for security research like that. And so it goes through and it's like, you know what, you have these 4 things, and we know that there are vulnerabilities in those 4 things. So you might want to update to these versions. Then for sure, you do not have this ticking time bomb in your app. Some of them will tell you, you have these 4 things, but one of them is exploitable. So you need to move this now. So it kind of depends on which SCA tool you get. So that's a starting thing you can do, which is the easiest and the fastest, but it's not the cheapest.
Mm-hmm.
And then the second thing you could do is like you can do this manually. So really large companies such as IBM, as of a few years ago, I don't know if they're still doing it, they would actually inspect every single package themselves because they're so huge, they can afford to do that and
Right.
actually
And by the way,
like approve
very,
them.
very few people can.
Yes, yes.
You know?
We are not all IBM.
No,
Like
no, no,
we're just
no.
not that big and powerful. And like, and that resource, like just to have so many resources to be able to do such a huge task. So another thing that like smaller companies will do that don't have a budget for such a tool, sometimes they'll use free tools like OAuth dependency check and OAuth dependency track. If you are using open source tools, you can use Dependabot. They like, I've heard people talk about how they don't find everything, and that's true, but for free, it is way better than nothing. But the other thing you can do is just look at all your dependencies. When someone made my website for me for We Hack Purple, I looked at all the plugins and I just Googled them all. And I was like,
Yeah.
this is the name of the plugin. I looked at vulnerabilities, breach, hack, like anything like that. And just like vulnerability, which versions are vulnerable. And it's just like, as long as we're, not on the super old version, we should be safe. And you can even set up alerts for those if you're really concerned, because WordPress core is quite safe and secure now. It's not updating your 4,000 dependencies that you have, like
Correct.
all the plugins or your theme that's 8 years old and hasn't been updated. And usually the vulnerabilities are actually in there. Another thing you can do is just look, is this plugin or dependency or whatever I'm using, is it just supported by one person who is a volunteer who
Right.
might have a life all of a sudden where they don't want to do this anymore? They got promoted, they don't have time, they had a kid, they found a spouse or whatever, and they're just like, I joined a soccer team and I'm going to just play soccer professionally now and I'm not going
Right.
to do this anymore. So if it hasn't been updated in a year or more, you don't want to use it. If it's only supported by one single person, you don't want to use it. It's better if it's supported by something like the Apache Foundation or the OWASP Foundation, where there's a group of individuals dedicated to this. So at least if a vulnerability is found, someone will fix it.
So for the
Yeah.
newbies who are watching this, who are learning on the fly, explain what OWASP is so people know what that
Oh,
is.
yeah. Okay, so OWASP stands for the Open Web Application Security Project. And it was started, I believe, 21 years ago in 2001. And it is an international nonprofit foundation that runs events like paid conferences all over the planet. And the conferences move around, some of them stay in the same cities. Then they also have over 300 now chapters around the world of groups of individuals in various cities. There's one in my city in Victoria. There's one where I used to live, Ottawa, where people get together. Right now, it's often virtually instead of in person. But basically, they get together and they teach each other and learn and network. And then there are also over 100 active open source projects that are part of OWASP. And one of them is Dependency Check and Dependency Track, which are sort of like sister projects, where one is where you run in the command line manually and it will find dependency problems. And the other one is specifically made for CI/CD pipelines. There's also another super famous project from them is called Defect Dojo, where it will suck up the results from all your different security tools and give you metrics and trends over time and like track who fixes things faster and stuff. It's really cool.
Wow.
Yeah, and there's a project that I started from OWASP called OWASP DevSlop, like sloppy DevOps, DevSlop. And it is an education project, and we have a zillion videos, and it's now led by this amazing human named Nancy Garishe. And basically, we just have people on, and they would just show us how to secure stuff with DevOps. Like, how is it different to do, like, let's say infrastructure as code or security as code rather than the old way we would do things. And so, yeah, they are a giant, huge international community of thousands and thousands and thousands of people who really care about making software more secure. And I'm a lifetime member. I'm a big, big fan.
Great. Let's talk about some other things. So one of the things that occurs, I'd say it's one of the low hanging fruit, is the hard coding credentials. We talked about the, in when I said I need to talk to you, was after hearing AWS, hard encoded, tokens and things like that. What are some of the ways that you can look for, you're spinning up a service as admin and the password is there, or again, the token is there. What are some of the ways that we can validate code looking for these kind of things?
Okay, so there's so many ways, David. So first of all, I'm super biased because I give training, but I think training is the start to explain, what are secrets? What is secret management? Why do we need to do this? So it's in the software developer's brain, and you teach them how to find them and how they should be managing them. Then you start reporting all the secrets in their code and making them rotate those secrets and check it into secret management. So right now, I've been seeing a big shift. So when I started in AppSec versus now, a lot of companies, if they have a CI/CD pipeline, or just if most of their code, hopefully, fingers crossed, is in all the same code repository or version control system, as you check in your code, but before it's actually committed, there's something called a pre-commit hook. So you can stop it right in that moment, run a test, and if it fails, you can stop the check-in. So the code's not fully committed. And in those pre-commit hooks, I'm seeing more and more companies run a secret scanner. So secret scanner is generally, it's a bunch of regular expressions that look through the code, just the brand new code that you wrote or you changed, for something that looks like a secret. So secret is a way that computers authenticate to other computers. So passwords are for humans, but secrets are for computers. And so it could be a hash, it could be a certificate, it could be a key, it could be a password or a connection string, etc. So it's something that a computer, like a service account, let's say, or an API or an application or database, trying to authenticate to something else. It's like, you can trust me, I'm the right API to access this database. I'm who you think I am, and I do have the rights to be here. And so ideally, more and more companies, and I am seeing this, will, instead of putting those secrets in the code, we'll put them into something called a secret management tool. Sometimes people call them a secret store, but there's tons on the market, varying prices. Every single cloud provider offers their own version, but basically it's accessed programmatically. So when I used to use Azure DevOps and I worked at Microsoft, I used Azure Key Vault, which is literally no surprise to anyone. Because it's all made by the same company, they all work together quite well. But basically, as we would check code in, Azure DevOps would say, no, Tanya, I see you have a connection string and there's a password in there. And I'm like, well, Azure DevOps, I'm trying to make an insecure demo so I could show it off at this conference.
Right.
And then I'm going to catch it later, Buster. So, and so then it tried to stop me from locking it in. And there were all these cool checks that we could do. So generally, when I start somewhere, the first thing I do is I want to scan the entire code repository. So you can sometimes just download the whole thing locally, unzip it because you have an amazingly sized hard drive on your computer, hopefully. And then you run this regex. It's very fast. Like, you can do a whole app in under 5 minutes, very, very fast. And then you have to sit there and dig through the results. So I often say, do you have any interns or co-op students working for you? Do you have any junior engineers that really want to get their hands dirty?
Yes.
And then you go through these results, and there'll be some false positives, and there'll be things that there's no business risk, so you won't change it, but it's still not a false positive. So I worked somewhere last year and we did that, and we found a software key, like a license key, but the software was 12 years old and the company had gone out of business somewhere between 5 and 7 years earlier. And so they're like, it's no longer a secret because that company isn't in business. And all it does is it sends these emails from our system. So we're going to keep using it. We own the license. But if someone steals that key, what are they going to do? Steal software that's no longer licensed. It's technically in the open domain because that company doesn't exist to hold the license anymore. So we're not really worried about that one. I'm like, okay, so then we could suppress that result from then on. And it's so common, Dave. So like last year, I don't really do pen testing anymore, but one of my longtime clients was like, listen, we're going to buy this company. Like, could you just take like a quick look, like just 2 hours, just take this quick look. And I found the company's banking password that was live. And I was just, and of course you're supposed to call your client first, but I called them first. And I was like, hi, I need you to go change the password right now. And I explained it. And then I was like, I'm going to give you an hour, then I'm going to call my client and tell them, but I don't want this to continue to be live where I have the possession of your real live banking credentials. Like, that makes me uncomfortable. And
I would agree with that.
Like, yes. So they changed it right away. And then we informed my client so they knew. And then like they ended up choosing a slightly different price as part of their acquisition because of all the vulnerabilities that we found. It wasn't terrible. It was like, it's going to cost, X amount approximately to try to fix all these bugs. It's going to take this amount of time and people hours. And so then they renegotiated slightly and they still came on board, and, I got to help them fix those things. So that was cool. But I think that companies are a lot wiser now. Like when they buy a company, it's like, hey, are we buying, we're buying your 25 apps you wrote. Like, are those
Correct.
safe? Are there
Correct.
things we need to know about? Or is there a ton of technical debt, et cetera? So I think that developers are more security savvy than ever before. But we still need guardrails to keep us on the right track.
Yeah, agreed. So let's talk real quickly, because Cymulate does breach attack simulation in a continuous threat exposure management fashion. Let's talk about some ways. We talk about shift left, and you talked about doing tests before pushing something out. And for example, we have a great use case. We talked about Jenkins and being able to go ahead and run attacks against a new build and say, no, it's less than this rating. It has to go back into development. Right? Talk about that for a second. What are some ways that you can add automation of these, continuous threat exposure management to help?
Oh my gosh, Dave, there are so many things. Okay, so I personally believe that security should start at the project kickoff meeting. And that is where you could say, like, here are security activities that we are planning throughout this project. And one of them is going to be like a simulation of a real attack of the system. And we're not doing it to give you old gray hair. We're doing it to find real threats, because when you do threat modeling, it's not, how do I word this nicely? So I find threat modeling extremely valuable, but it's not the same impact as when you say, I have your production real banking credentials. It's just not the same as, there is a potential risk that we could have hard-coded credentials, and like theoretically this could happen. Or for instance, if there's money in a system, one of the threats is always someone will try to steal the money because people like money. Criminals especially really like money. I have a feeling you and I both have this in common. Most people listening are probably like, money's pretty great. And so people want to steal the money. But it's totally different when you see an attack simulation and how your product or your teams truly actually react to the thing, which is why I'm often suggesting like tabletop exercises, or like you did, attack simulation. I used to work at elections, and it's not a secret at all that they run an entire election 6 months before every real federal election, and they invite hackers. They throw security incidents in, like they do all sorts of like, they build a real office. They have real humans come in and pretend to vote. And they do all of this to see what the problems could be. And I remember one of the things was the font was size 6 on a printout.
Oh my
and
God.
Like half of us just couldn't read it. And it was stressful. And it's like by the end of election day, which is like, I think 18 hours long, it's like, so we're like, right. How does font 18 sound? And so you find out these little things that could cause problems. And so if you actually have a real simulation of an attack on your system while it's running, it's a lot more accurate. Does that make sense? Or do you agree?
Totally makes sense. That's totally makes sense, which is awesome. So I'm starting to ask everyone a general cybersecurity question, right? If there were the top 5 things that you would say, and this is beyond our conversation about DevOps and AppSec, it's in general. If you had a list of things that low-hanging fruit, what are the top 5 things that you would say that is?
Okay, so I think that all developers should take some sort of secure coding training, and my training's free, so there's no more excuses that they can't afford it.
And by the way, give a URL to the training.
So if you go to https://community.wehackpurple.com, you join the community, which is free. And then I think we have 11 or 12 courses now, and all of them are free, including the secure coding course. There's
awesome
secure infrastructure as code. There's all sorts of stuff, incident response, etc. But I think that just having training, because every student I talk to in a boot camp, a university or college, none of them have any training. So that would be the first one. Actually show them what you want from them. So 2, a secure system development lifecycle. So if you work somewhere, whether you do waterfall, agile, DevOps, or some other methodology, I don't care, have at least one security activity as part of your SDLC. Ideally, so in my dreams, you have one in every single phase. So you're going to have you're going to have requirements. Cool. Here's the security work requirements. Oh, you're going to do design. Cool. Let's do threat modeling, or let's whiteboard out your design and ask some pertinent questions. And so if each phase of the SDLC, including maintenance, after you're out in production, continue to have security events occasionally to check in that the app is still safe. So first one, training, second one, secure SDLC. So third one, input validation for everyone all the time, and testing of that input validation, like super thorough testing of the input validation. Yes, please. And then, as silly as this might sound, outputting coding, because cross-site scripting is still so popular, Dave. It's in over 50% of the websites on the internet, according to OWASP.
Yeah.
And like, it scares the bejeebies out of me. And then fifth, we still have injection vulnerabilities all the time. And we still have specifically SQL and no SQL, so like MongoDB, etc., like Postgres, etc. So just any sort of query language for a database, you should be using a parameterized query. So what that means is, instead of like taking a bunch of input from the user, pasting it all together, and then sending that, select star from table users where table name equals like this, you just send the parameters to your database. The database opens up your parameterized query, plugs them in, and removes any opportunity for any sort of injection of code. And so if people did those 5 things, first of all, like OAuth could breathe a little better at night. So could I, like all of us application security fans, people who find this important, we'd just be like, oh, like life would be way better, Dave.
It would be.
Yeah. And if I can add one more, so like if I had a wish and you were a genie, it would be that every single place that teaches coding included security.
Yeah, and by the way, that has to happen. That totally has to happen.
Yes.
Yeah, embedded from the start. Embedded from the start,
I wrote a book for universities, and none of them wanted to pick it up because they're like, well, we don't have anyone to teach it. And the way that academia works, they pay so very little. It's basically like volunteer work. Yeah. And so then I tried to automate courses for them, and then they said that wasn't acceptable. So then I actually just put a lesson for every single chapter of my book for free on my YouTube, because I was just so sick and tired of hearing excuses from universities. Yeah. I'm like, you're $1 billion organization and you want to pay me less than a Walmart greeter to teach new students?
Yes.
No.
Yes.
If I'm going to do it, I'm going to do it almost for free, Dave. I'm like, why not just do it for free on my own terms?
Correct.
So I did.
Correct. Yeah, and that is the trouble with academia these days, right? Is that it's just they need to make it worth its while. And in some ways, it may be better for you to consult universities for a fee and say, I'll give you that, I'll trademark this. But again, you get into the thing of money and stuff like that. Well, excellent. Well, Tanya, thank you so much. This is so awesome. This is so helpful. This is phenomenal. And I think that people got real value out of this. And the idea is, again, in DevOps and AppSec, this rocks. This is exactly a guideline to go for to be successful. We're having you back. We're having you back in 2023 because you're so awesome. And thank you so much, everyone. This is Dave Klein. This has been the Cymulate Cybersecurity broadcast.
Bye.